In this lesson, we'll calculate coordinates of a point P on a unit circle because they are going to give us ultimately values of cos theta and sin theta for given value of theta. So for that purpose, let us consider a point P on the unit circle. Unit circle means radius is equal to 1. And if coordinates of this point are x and y, this means that y is the vertical distance of point P from x-axis and x is the horizontal distance of the point P from y-axis. So let this be y-axis. If central angle is considered as angle theta, then values of basic trigonometric ratios sin theta and cos theta can be defined as cos theta is equal to x over 1 and sin theta is equal to y over 1 because r in this case is equal to 1. This means that x is equal to cos theta and y is equal to sin theta. So if we find coordinates of point P, these are in fact values of cos theta and sin theta for whatever the given angle at the center is. When theta is equal to 0, so let's do this. When theta is equal to 0 degree, we know that x is equal to cos of 0 degree and y is equal to sin 0 degree. Sin 0 is equal to 0 and cos 0 is equal to 1. We calculated this in the previous lesson. So coordinates of P here in the starting position are 1, 0. If we have these coordinates, we know that abscissa for this point is 1, which is value of cos 0, and ordinate for this point is 0, which is value of sin 0. Now when theta is equal to 30 degree, let's take this one. When theta is equal to 30 degree, then what would be the values of this point P here? When theta is equal to 30 degree, then x would be equal to cos of 30 degree and y would be equal to sin of 30 degree. So cos of 30 degree is equal to under root 3 by 2 and y is equal to 1 by 2. So let us associate these values as coordinates of the point. So this would be under root 3 by 2 and this is 1 by 2. Similarly, if we find values for theta is equal to 45 degrees, x is equal to 1 over under root 2 and y is equal to 1 over under root 2 as well. Therefore, coordinates of P would be here 1 over under root 2 and 1 over under root 2. And when theta is equal to 60 degree, let us make theta is equal to 60 degree here. The value for cos 60 degree will be the abscissa, which is 1 by 2. So this is 1 by 2 and the value of sin theta at theta is equal to 60 degree is equal to under root 3 by 2. So this gives us a good tool to find values of trigonometric ratios. And here for theta is equal to 90 degree, this P will have coordinates 0, 1. If you take a look on the abscissa mean the first part of the coordinates is the values of cos theta, which goes from 1 to under root 3 by 2 and then under root 2, 1 over under root 2 and then 1 by 2. It decreases from 1 toward 0 by these 3 numbers. So when we come back from 90 to 180 degree, the next coordinates for cos of 120 and sine of 120 will follow a definite pattern, and this time the cos will swing back into those numbers. So this will be 1 by 2, but this time because the point is on the left side of y-axis, so cos is going to be negative. So this will be minus 1 by 2, minus 1 by 2, but y is still going to be positive because it's above x-axis. So this is under root 3 by 2. And then minus 1 by under root 2 and 1 by under root 2. And next would be minus under root 3 by 2 for cos, under root 3 by 2 and 1 by 2, and next would be minus 1, 0. Minus 1 and 0. In third quadrant, both x and y are going to be negative, because if this is the angle theta is equal to 210 degree, if this is 30 degree angle, then the previous angle which has already been consumed is 180 degree. So the total angle makes 210 degree. For this, x is going to be negative for this point P. For this point P, this is y, which is clearly negative because it's going below and below x-axis, and it is on left side of y-axis. That's why x is negative. So here x is negative and y is negative throughout third quadrant. So here negative x, negative y, both, and they will again swing back into the same pattern of numbers. So this cos will become equal to minus under root 3 by 2, minus under root 3 by 2 and minus 1 by 2, and next it will become minus 1 by under root 2 and minus 1 by under root 2, and next when theta is equal to 60 degree in third quadrant, making total angle of 240 degree, this will become minus 1 by 2, minus 1 by 2, and sine will become minus under root 3 by 2. So here it will become 0, minus 1, and in fourth quadrant clearly x is going to be positive. In fourth quadrant x is positive and y is still negative. So the next number will be, x will become positive, so this will become 1 by 2, and sine will still be negative, so this will be minus under root 3 by 2, and this time it will be 1 over under root 2 minus 1 by under root 2, and in fourth quadrant this time this will become under root 3 by 2, under root 3 by 2, and minus 1 by 2. So this is how we can find. All what we need to learn is that initially theta is equal to 0, then it makes angle 30 degree, 45 degree, 60 degree, 90 degree, and then 210, 135, and 150, 180, 210, 225, and 240, and 270. And this way you can find any value of cos theta or sin theta, whatever value of theta is. So this is called a unit circle. Or otherwise, there is another way of remembering how you can find and memorize these units. If we make this as sine, cos, and tan. Let us make this as 0 degree and this as 30 degree, 60 degree, 90 degree, 120 degree, and 150 degree, 180 degree, 210 degree, 240, 270, 300, 330, and 360. So these are all the values of angles with a 30 degree distance. So if we remember only 4 numbers, 0, 1 by 2, and under root 3 by 2, and 1. These numbers are going to oscillate. They will come back now. It will be again under root 3 by 2, and then 1 by 2 again, then 0, and then will swing back to 1 by 2, under root 3 by 2, and then 1, and then from 1 it will swing back. This will be under root 3 by 2, under root 3 by 2, 1 by 2, and 0 again. But remember that in first and second quadrant, sine is positive. In third and fourth quadrant, values are all negative. So after 180, this is negative, 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 negative. So this is how you can get the values for sine. For cos, numbers are going to remain same. It's only the starting point will be 1 this time. So here we have 1, then under root 3 by 2, and then 1 by 2, and then 0, then 1 by 2, under root 3 by 2, and then 1, and then under root 3 by 2, and then 1 by 2, and then 0, and then 1 by 2, then under root 3 by 2, and then 1. The value of cos is positive only in first quadrant and in fourth quadrant. So the values of cos would be negative in second and third quadrant. That's it. And tan theta can be found simply by dividing values of sine with cos. So 0 over 1, 0. So this is 1 over 2 times 2. So this is, if we divide 1 by 2 by under root 3 by 2, this will give us 1 over under root 3. And this will be under root 3. And this will be infinity, which is undefined. And these things will be periodic the same way. 1 over under root 3 and 0. And then 1 over under root 3. 1 over under root 3, under root 3. And then undefined, then under root 3, then 1 over under root 3, and then 0 again. But tan is positive in first quadrant and in third quadrant. So second quadrant it will be negative, negative, and fourth quadrant it will be negative again. So this is how, if we want to find out value for cos of 210, you can look at the row for cos under the column 210, which is minus under root 3 by 2. This is how we can find the values of sin theta and cos theta for any given value of theta.